Alright, chapter 6, review, page 360, number 55. It says, use analytic methods to find the exact solution. Okay, so there's at least two ways of doing this. So normally when you're given a differential equation and initial value, you would integrate it. So you can integrate this by separating the variables. So you can move the p's over, so you're going to end up integrating all this p stuff, and then maybe leave just the 0.002 and integrating it, going through all of that, and then use the initial value of 0.50, and then you'll have your logistics growth equation. This is the differential equation, and this would be the original growth equation. Just to show you what, if you're given like this as our differential equation, we can move the p's over, integrate it, so you'd have to do partial fractions. So this is just the general formula, one of the several general formulas for different, sometimes they'll multiply by p, sometimes they'll divide by, or an m divide by p. Anyways, you integrate it, partial fractions, and do some tricks like I have p, natural log of p over m minus p. That's not good enough, you have to invert it, so take it to the negative first power. Then you could solve, and you eventually get our original m, the population is the maximum over 1, so m is the carrying capacity, the maximum population over 1 plus a, which is just a constant, e to the negative kt. So that's the general, to go from our differential back to our original. That's how you would do it. I'm not going to ask you to do this. So that'd be the long way of doing it. A short way, the way you can do it, is to kind of use the models provided. So we have, here's two of them, the differential equations here. So looking at what we have here, that's our given equation, and what we have here, this is the one we're going to use. So it's dp dt over p equals k1 minus p over m. Okay, so in ours, notice this is the books, they divided by p. So on ours we can divide by p, so that just moves that p underneath this, and then we would be left with our k. Alright, so our k, once we divide by p up here, would be 0.002. So by inspection of our differential equation, our k is 0.002. Also, comparing the two, this m would be 800, so the maximum of the population, the carrying capacity, is 800. So that's a couple different variables that we know. So our original, this is also in the book, it's the one I derived, that's the general equation for the population logistics growth. So p equals m over 1 plus a e to the negative kt. So we know k and we know m. So p equals 800 over 1 plus a e to the negative 0.002 t. So we're close. All we need now is to find what a is. And we do know p of 0 equals 50. That's given to us. So we can plug in 50. And 0. Okay, so that all makes 1. So I have 50 equals 800 over 1 plus A. Divide by 50, and so A is 15. So our equation would be P equals 800 over 1 plus 15 e to the negative 0.002 t.